about the Earth, really talk about survival. We could talk about the poles where the cold is unrivaled. The Arctic top of the world got people and polar bears. Antarctica, crazy penguins chilling down there on miles and miles of ice and glaciers. But something ain't straight with our polar neighbors. It's a change in the climate, a change in the weather. It's heating up now, but it's not for the better. See, the heat comes down from the sun to the earth, but now the heat can't escape, it just can't disperse.
Hi, welcome to the NASA Explorer School's e-Professional Development featuring the Earth Climate course. Today we'll be sharing with you how this course helps explain the factors that affect the habitability of a planet. And specifically, we want to explore what determines a planet's climate. So what we're going to do is drop in on science teacher Jean-Dar Bradshaw's class as they conduct the same activities that you'll see here, so that you get not just a feel of how to do them, but also how they look in your classroom. All of the resources that you'll see in this session will be available on the NASA Explorer School's virtual campus. Now, these course materials were developed by the Goddard Institute for Space Studies in cooperation with the Earth Institute at Columbia University. And we're fortunate to have an interview with one of the developers of the course, Dr. George Tselioudis, who will talk with us about how the course came together. Let's watch.
The main objective of the Earth Climate course is to introduce the students to the actual research process and to have them realize the importance of the process itself, but also of the research results in everyday life. So first of all, the motivation, this is an Earth Climate course. The motivation is what we call good planets are hard to find. We introduce different planets of the planetary system and make the students realize that in terms of the actual climate, the Earth is the only habitable planet. And the question is why? Why is it that the Earth's climate is just right for humans and for living beings, and it's not the climate of Mars or Venus? And this is the motivating factor. This is the question that we start with. And then we go through a research process that begins the same way that most research projects begin. So we start the process by having the students make actual measurements of little box models of planets. They have a light source and they measure the temperature of the planet as they move the light source or change the color of the box planet. And we have them write down the observations that they make, for example, the temperature with respect to the distance of the box from the light source. And once they do that, we have them write down their measurements in tables, and then we have them start looking at relationships between things like the temperature and the distances, or the temperature and the reflectivity of their surface. And once they write down those relationships, we ask them to draw lines, best fit lines on them, and write down the equation of those linear regressions. And then we have them realize that they've just built a mathematical model of the process that they were studying. So once they do that, once they realize how it is to build a mathematical model from observations, then we tell them that you can also build it from physical laws. And then we give them some Excel-based, a little more complicated models of the Earth, where they can study things like what happens if we double the carbon dioxide in the Earth's atmosphere, for example, or what happens if we double the amount of ice in the Antarctic or the Arctic. Questions of that sort that they can solve with those more complicated Excel models that we provide for them. And then they end up making studies of what makes one planet habitable and another less so in terms of the climate. The good thing is that once they're using those more complicated Excel-based models, they've already built their own simple linear regression types of models from their observations, so they understand what goes behind mathematical models. So they don't use them as black boxes. They have an understanding of what it is that's behind them and why it is that they can use them to study questions like what's going to happen to the Earth's climate if we double carbon dioxide in the atmosphere. So that's what we try to achieve, and we try to achieve a research process where we start from observations, measurements, physical laws, and mathematical relationships that end up in mathematical models. And because this is what actually we do here. We use NASA observations of the Earth, satellite observations of the Earth, and we use those observations along with physical laws in order to build mathematical models and try to predict how the climate changes in the future. So this is our research, and this is the NASA research that we're performing here, and this is what we try. This research is what we try to infuse into the Earth Climate course, and we hope we did that with some success.
So as you can see, a lot of thought and time has been put into these modules, making them authentic to current NASA research. Joining me today is my colleague Joan, who will be talking to us about the activities and their ties to the national standards. Joan?
And that was special, hearing it actually from one of the lead writers and developers. This course was actually designed for high school students to be conducted over a multi-week period. We have taken 3 lessons from the course: modeling hot and cold planets, experimenting with computer models, and exploring the effects of atmospheres on planetary temperatures. And we have adjusted them just a little bit to address National Science Education Content Standard D for the middle school. And that Content Standard D addresses Earth in the solar system. We're going to look at Earth as the 3rd planet from the Sun as the major source of energy for the Earth, and then reasons for the seasons.
Thanks, Joan. Now we have an opportunity to take an introductory look into Mr. Bradshaw's class to see the activities that we will be introducing over the course of this EPD session.
The kids really looked like they were having fun, didn't they?
Oh, they sure did. And so we're going to get started here in just a second, but that's going to be the start of our next module. And so we'll be getting ready for the setup and then looking into what it is that we're going to be doing with those experiments, starting with our next module.
Yes.